This is extra example number 3. So we've got an equation that we're going to solve here. G squared equals 45. So when we have the squared symbol, to undo that operation, we need to take the square root of both sides because that's the opposite operation. So we're going to write it to both sides here to show our work. And remember, the reason we're taking the square root is because we want to undo the square, and it's asking us what number times itself is that number. So on the left side here, we're asking, hey, what number in g squared is being multiplied by itself? Well, that's g. So the square root of g squared is just g. Then on the other side, we need to take the square root of 45. So we need to ask ourselves, what number times itself is 45? Oh, that's not going to be a nice number. So our answer here is going to be irrational because we don't know the exact square root of 45. So this is where we're going to have to estimate. So in order to estimate, there's a couple different ways we can do it, but we're always going to start off the same. We're going to look at numbers we do know the square roots of. So I don't know the square root of 45, but I do know the square root of 49, and that's bigger, so I'm going to put that on the right side here. So square root of 49 I know is 7, but I don't know the square root of 45. So I need one below now. So I don't know what the square root of 45 is, but I do know what the square root of 36 is. So that's going to be the lower one. So it's close to 45, but it's not quite 45. 36 is close. So you always want to get the two closest. And we know it's the two closest because the square root of 36 is 6, the square root of 49 is 7. So these two numbers will always be right next to each other. They're going to be consecutive. So 7 follows 6. That should always happen. So we know that the square root of 45 is somewhere between 6 and 7. In order to figure out what the decimal is, because we're going to round to the nearest tenth, we need to do some estimating. So we right now know that our answer, first of all, it's going to be positive and negative. We'll talk about that in a second. And the exact answer is the square root of 45. Because remember, this is irrational. It has a decimal that goes on forever without a pattern. So to represent that whole decimal, we can just leave it as the square root of 45. But it's the positive and the negative. But we do want to estimate it. That's part of the skills in this, one of the skills we are learning in this chapter. So we do need an approximation. So G is approximately plus or minus, and then we're going to estimate. Since we know our numbers between 6 and 7, we know our answer is going to be 6 point something. To figure out that point something, we need to know where on the number line square root of 45 lies between 6 and 7. So to figure that out, we have to start by putting a number line with 36, 45, and 49. So, and we can also do it with long division. So let's do the spacing way first. So here's 36. We know that, I'm going to rewrite that actually. So we know that here's 36, and 36 is 9 away from 45. Add 9 to 36 to get 45. Then how far from 45 to 49? That's 4 units. So we can see that it is closer to square root of 49, so it's closer to 7. So on the number line, I'm going to say if this is 36, I'm going to go out and I'm going to say that is going to be where 45 is. So that's 9 units. If this length, if I'm saying this length is 9 units, I need to go only 4 units more to get to 49. So something like this, this length right here, that can't be 4 units because this whole thing is 9, so there's no way this is 4 units. 4 units would be about half this because we know that half of 9 is 4.5, so it's close to 4. So about half this length, a little less than half that length. So maybe something like that would be 4 units. So the reason we need to pay attention is because in order to get an accurate estimate, we have to have the spacing of these numbers correct. So that's another 4 units there. All right, now we're going to actually look at the square roots of these numbers. So that's the spacing of 36, 45, and 49 on a number line. Now we're going to look at the square roots because the spacing stays relatively the same. So this is 6 now. This is still square root of 45, and this is 7. So now, instead of looking at a number line from 36 to 49, I'm looking from 6 to 7, but I know where to place the square root of 45 now because I started off with the numbers under the square root. So now you're going to mark smack dab in the middle of 6 and 7, which is 6.5. So if this is 6, this is 6.5, and this is 7, to the nearest tenth, what would this be? So this would be about 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9. So I'd say it's somewhere between 6.6 and 6.7. I'm going to go 6.7. So a good estimate is about 6.7. And it's also negative 6.7, right? Because of the plus or minus sign, that means we have positive and negative. 6.6 is okay too, but definitely not 6.5 or under. Okay, here's the other way you can do it. You can actually do the way with long division. So we know that the full length from 36 to 49, that full distance is 13 units. Okay, so the full distance is 13 units. Well, where does square root of 45 lie on that? It lies 9 out of those 13 units away. So think of it as steps. Steps from 36 to 49, there's 13 steps, and 45 lies on the 9th step. So 9 out of 13. So that's going to help us get a really good estimate if we look at it's 9/13 of the way from 6 to 7. So we got to figure out what that is as a decimal. So 9/13, if we do that long division, 13 does not go into 9, so that's 0. And then we add a 0 here. Make sure you're putting your decimal places. They have to line up. So this is the ones place. This is the ones place. We know this is going to be between 0 and 1 because the numerator is less than the denominator. Okay, and then how many times does 13 go into 90? Well, you're just going to have to start adding 13s. I know that 13 times 3 is 39, though. That's an easy one to remember. 3 times 3 is 9. 1 times 3 is 3. So 39. Oh, maybe I can do two 39s. 39 plus 39. 9 plus 9 is 18. Carry the 1. That's 3 plus 3 is 6 plus 1 is 7. Maybe I can get one more in there. One more 13, that is. So 13, 11. Nope, not quite. That would be 91. So this was 3 13s, another 3, so that's 6 13s. So it should be 6. So that would be 78. 13 times 6 is 78. Because remember, this extra 13 was too big. It made it 91. So we're going to subtract 78, and we shouldn't get more than 13. When you're going to subtract here, you can add up. If you had $78, how much more money would you need to get to 90? And that's 12, but you can still do borrowing if you want to. So we can't take 8 from 0 here, so we got to borrow. So we're going to come over to the 9, and that becomes 8, and then our 0 becomes 10. Now we're looking at it as 10 minus 8, which is 2, and then we have over there is 8 minus 7, which is 1, so 12. Now we add a 0 before we ask ourselves how many times 13 goes into it. So now how many times does 13 go into 120? Well, it was 6 times for 78. It's 7 times for 91. So let's see, can we get another one in there? And the only reason we're going one more is because our answer needs to have a tenths place. So we're going to the hundredths to see if it needs to round up the tenths place. So over here, let's add it one more time. So that would be 4 and then 10. So 104. Oh, we can get another one in there. Add one more 13. And that's going to give us 117. Okay. So 117 is what we're going to be able to take off. And again, let's add up. So 117, if you had that much money, but you needed 120, how much more money do you need? Just $3. So don't make the subtraction too difficult or too complicated, okay? But how many 13s is that? So this was 6 13s. That's 7, 8, 9. That was 9 13s. 9 13s, I'm sorry. Okay, so we can stop just because all we needed was these two place values so we could round to the nearest tenth. Well, that 9 is going to round that up. So our first estimate by just using the number line and gauging based on our spacing is pretty good. 6.7, I would say, from this way as well, this method of doing it, 6.7 is a great estimate. So about 6.7 or plus or minus 6.7 is our answer. And that's it for extra example number 3.